Right. Hi everyone, welcome to another episode of Rocking DFT. So guys, I have promised you that I'm going to bring some distinguished guests in my podcast, and today I'm fulfilling that promise after a long time. So we have a very good distinguished guest in our studio today. So his name is Umesh Vasant Hulikol. So hi Umesh, how are you? Yeah.
Hi Kshitish,
Yeah,
how are
hello.
you doing?
I'm good. I'm good. So I'm really very satiated and happy after a long time, actually. I'm just having a podcast with another distinguished engineer. So really a very good, kind of ambience for my ecosystem I'm building. I'm thinking in that direction. Okay. So before going further over the discussion, what we have proposed today. So I'm just going to give a brief synopsis about your background and profile, right? So Umesh, he's having 18 plus years of professional experience in ASIC design verification, emulation, and pre-silicon validation. He's having a distinguished career with focus on the ICE emulation platform development and bring up simulation, acceleration, and SOC functional verification. He's having a very good cognizance of the different SOC architectures for client SSD, enterprise, storage, networking, and graphics design, having a good focus on the emulation platform, bring up productivity improvement with the architecture automation. And he's having a exemplary, kind of an expertise on the different emulation tool sets. For example, the Velos tool sets, tool suits, the Palladium, Protium, emulation platforms, Pacman, Elite, NCSIM, all those kinds of tool sets. And if I just talk about kind of the merits, like, so he got awarded with an Extra Mile Award for the customer engagement with the mentor Siemens, presented a paper at SNUG 2010 conference on the high-speed serial interface implementation on FPGA platform. And he has also published a paper on implementation of high-speed serial interface on HAPS platform at techonline.com. So I must say, yeah, the kind of an expertise you are having on the emulation is quite exemplary. So I hope, the today in this particular podcast, whatever the discussions we are going to have with each other, so it's going to benefit our viewers. So it would be a kind of a knowledge session for everyone who's going to watch this particular YouTube. This is on the particular YouTube channel, okay? So that's my expectation about this particular podcast. So I just open the floor for you. So do you have any opening comments about this podcast and about the knowledge session, what we are going to have? Do you have any opening comments?
Yeah, Kshitish, good to see you
Yeah.
after quite a bit of time,
Mhm.
and hello to everybody who is going to watch it.
Okay.
So it's my pleasure to discuss some things which I know on emulation with the audience.
Right. That's really very good. Yeah. So I hope the audience is going to get some benefits out of this discussion. That is the expectation. Right. Okay. So without taking much time, so let's just quickly deep dive in this particular session. So just in the layman terms, right? There is a lot of hoopla is going on about the emulation, the cutting edge methodologies around this particular, domain called emulation. So I just want to throw a basic question to you. What is actually an emulation? Can you just introduce the emulation in the layman terms to our audience and the kind of a prototyping work associated with it?
Sure.
Yeah.
So basically, as you know the IC flow where
Mm-hmm.
you have a get a spec. Based on that you do the RTL design, then you implement it, and you synthesize it, you stitch in the DFT, then you do the PNR, and you create the RTL to GDS to all that flow is there. Here, the design that you have, the RTL that you write, it has to be validated somewhere. And one of that methodology is verification, where you do the verification, ASIC verification of the design. But traditional verification has been slow as compared to the currently as the technology is growing, and it's the designs are really becoming very fast, so test methodologies also have to be very high. Like earlier, say uh, a data of a few MB you would test, transferring few MB of data in simulation. Even that used to take a lot of time. Today, if you want to test all the cases, you need to really be able to transfer GB of data between, say, a hard disk and which a design is between two designs, like a hard disk and a controller or a PC. Now, that kind of a scenario, if you want to test, traditional verification is not going to be very useful. It has its own limitations with respect to times. It can take a matter of days to weeks to do it. And that is where emulation comes into picture. So emulation, in a layman's term, I'm talking, is you put your design uh, on uh, a platform, which is the emulation platform. Now, you port your design on that platform, and then you either give it some stimulus and then run some tests, and you see what is the real what is the operation, or how does it function in real time. It is much closer to the silicon, because on simulation it is software based, here it becomes hardware based. So it is more closer to what we do on silicon. So that's the a very basic terminology of emulation that we are having.
All right, all right. So Umesh, okay, that I have understood, right? In the layman's term, what is the basic definition of emulation, right? How we are going to define it. But in the regular ASIC design flow, what is the actual usage, where it is going to land, this particular emulation flow? Yeah.
So emulation
Mm.
has its benefit in multiple ways. Okay, emulation can be effective in first verification, as I said, verification of your design. Number two, it can be used by validation teams for validating your their some of the real issues, use cases that can occur in silicon. It can be used to left shift software development. It can also
Okay.
be used to simulate some special cases like DFT acceleration,
Mm,
DFT simulation acceleration.
mm,
You
mm,
are the DFT person,
mhm.
so you know
Right.
how DFT acceleration can be uh, very a daunting task when you do it in the traditional way. So DFT acceleration, low power acceleration.
Mm,
There are various methodologies or where emulation has been used and it has been deployed successfully.
mhm. Okay. So right now there are many terms like different kind of the teams which actually work close with each other, right? In the ASIC design flow. For example, we have an verification team, we have an validation team, right? So, what is the actual advantage for verification, validation, and software development with respect to the emulation perspective, right?
Okay, we
Yeah.
can go one by one.
Mm-hmm. Mm-hmm.
Verification, the biggest advantage is time saving.
Mm-hmm.
So some of the tests that you run on in verification, which are going to be time consuming. Say you want to test Ethernet data packet or Ethernet data connectivity or data transfer of few hundred MB, or 5 GB or something like that.
Mm.
That test you cannot run on verification. That
Okay.
you can put on emulation,
Mm-hmm.
on an emulator, and that can save your time considerably by like 40 to 50x. I'm just giving you a hypothetical example. It can be much more, but I'm just
Mm-hmm.
giving you a traditional
Okay.
very conservative estimate of how much saving you can have. And
Right.
I can give you a very small indicator. So if some test takes, say, uh, 50 hours, and if it you are able to run it in, say, 2 hours, I mean, you can anticipate how much fast it can go. So
Right.
you
And
are
you can save the test
saving
cost as well, right?
yeah, test cost is also there.
Yeah.
So that
Right.
is for verification.
Mm-hmm.
Validation, if you see, validation have to test a lot of use cases
Mm-hmm.
where the silicon you will be there, and you cannot test all of this on
Mm-hmm.
in verification many a
Right.
times.
Right.
So that is where emulation comes very handy. It is very useful.
Mm-hmm. Mm-hmm.
It could be a lot of power related cases, power tests, or any customer specific use case where a certain function has to be tested. Those kind of things, validation will benefits greatly from.
Okay.
Software development,
Mm-hmm.
it's very effective because of the simple reason that, see, software cannot start after a silicon arrives.
Mm-hmm.
Going
Right.
by the traditional flow, it has to
Mm-hmm.
start much before the silicon arrives.
Mm-hmm.
And for them, they need a platform where they can, which will be similar to silicon,
Mm-hmm.
if not 100%, 98%, 95%. If it is
Right.
same, similar,
Mm-hmm.
that is good enough for them to start with, and they
Right.
can start using that uh, platform and start software development much early. So it gives a big shift left for software development.
Mm-hmm. Mm-hmm.
And
Mm-hmm.
again, I'm not talking about the other benefits of for verification, like faster coverage improvement, low power verification.
Right. Right.
Those
Right.
things
Right.
are already there. So
Mm-hmm.
this is where it comes very handy. Emulation is technology is
Right. Right.
been very useful for some
Mm-hmm.
of these use cases.
And as you mentioned about that it is going to be used for the DFT accelerator as well, right? So in the DFT domain, the main thing, like, where we struggle, that how much test time we can reduce. Okay. And if we are going to, if we are able to reduce the test time, the test cost will also go down. So that is the basic funda, right? We actually create lots of tests in that regards, the whole infrastructure ecosystem we have to build, so that at the end, eventually or gradually, we are going to reduce the test cost. That is the basic struggle what the DFT engineer has to go through. So pertaining to that, so emulation, I feel it's going to help a DFT engineer a lot, right?
Yes, I have to add a
Mm-hmm.
bit on
Mm-hmm.
this. So when you develop all the tests and the
Mm-hmm.
test infrastructure, now
Mm-hmm.
it is very important that before the silicon arrives, your test patterns and the infrastructure is tested well
Right.
ahead of time.
Mm-hmm.
Otherwise, once the silicon arrives, you will always, on the tester, it is going to be very difficult
Mm-hmm.
to, check those things. Hey, my constraint was wrong, or any other issue was there.
Right. Right.
So that the traditionally has been done by running
Mm-hmm.
the creating patterns and running them
Mm-hmm.
on simulation,
Right, right,
and
right.
that has been a very slow process. In fact, at times where I have seen uh, uh, design teams do not run all the patterns there.
That is true. That is true.
So
Mm-hmm.
that when we put on emulator,
Mm-hmm.
you can uh, save test pattern testing the pattern testing time drastically, and it
Mhm.
cuts your test time, as you
Right, right.
rightly said.
Right, because as a DFT engineer, right, the first main hurdle what we need to cross is the simulation. So when we generate the test pattern, we run the entire simulations, but we can't run the simulations for each and every pattern, right? So we need to
Yes,
create a subset of the test pattern where we feel, okay, the test coverage is high, and that this kind of a pattern set we can provide to the tester, right? So that we can just test them, but it won't be a comprehensive testing. We are not testing everything. So that is a bit kind of a struggle what the DFT engineer is having. So in that case, if the emulation is going to help us, okay, in reducing the test time, so it's kind of a major kind of big boon for the DFT engineer, what I feel.
absolutely,
Right,
absolutely.
right, 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 right. Okay, so yeah, so that's we have understood, okay, what is the basic advantage we are gonna get when we are having this emulation platform, and what is the advantage of the verification, validation, and the software development when we have this kind of an ecosystem in place, right? Now, in terms of the market, right, there are many, many tools which are available, right? There are the different kind of emulation platforms which are available. So can you just give a brief, comprehensive view about the different emulators which are available in the market and what are the different flows they can support?
Okay,
Yeah.
so basically nowadays most emulators support the two major flows which I'll talk of. But
Mm-hmm.
first, let's start with what are the important emulators that are available in the market.
Mm-hmm.
Uh, so from the leading EDA vendors, we have uh, Palladium from Cadence. Uh, then we have uh, uh, Zebu from Synopsys,
Mm-hmm.
and we have Veloce from Siemens Mentor. Now, just to add on this, uh, the Palladium, each of this technology is different that both these all these emulators deploy or they use.
Mm-hmm.
So Palladium is it's an array of Boolean processors that they use. Uh, Zebu is off-the-shelf FPGA based technology, and Mentor is a custom FPGA based technology. So they are three different technologies on which they are built basically, and
Okay.
every this has its own advantages, and
Mm-hmm.
it has its own merits and demerits. But most of the flows that are supported in both of them are, first is the test bench mode, where you can even use your existing test bench and run tests on the design which is ported on an emulator. And the second one is the in circuit emulation, where you connect the real world peripherals and you
Okay.
test it.
Okay.
So that kind of a flow is used for performance testing.
Okay. So you have worked on all the different kind of suits which are available in the market, or on one particular
Yes,
suit you have a quite a good
most
expertise? Yeah.
mostly on all of them.
Okay.
But as you know, I
Mm-hmm.
work predominantly. Uh, we have worked on Veloce and Palladium more, as you know. So
Mm-hmm.
for extended period of time, we have used them. So
Okay.
those are the ones that I have worked more on.
Okay. So which one is your favorite actually? If you can just give a little bit statistics in terms of pros and cons kind of a thing for the viewers.
Well, it's very difficult to pinpoint because these
Mm-hmm.
technologies and emulation
Mm-hmm.
uh, platforms, right? They keep evolving over a period of time.
Okay.
Uh, like
Mm-hmm.
like Palladium had as a Z2. Now I think they're coming up with Z3. Veloce is having a Strato. Zebu is also coming up with something called EP1. So they are
Okay.
all upgrading it. So it's very difficult to name
Mm-hmm.
that, oh, this is good here or that is good there.
Okay.
All are there and comparable.
Mm-hmm.
Uh, like Palladium is very good in ice flows.
Mm-hmm. Okay.
Uh, Other software development is good with Zebu.
Okay.
So it is very, very subjective. You can't just pinpoint
Okay. Which one
something
is
like that.
quite popular in the market right now? Most of the companies, if they are using that particular tool set, do you know that?
I mean, Palladium is quite
Mm-hmm.
popular.
Okay.
Cebu is used
Mm-hmm.
in equal measures.
Mm-hmm.
Uh, and lately, VLSI also has come up with its new uh, emulator. So they
Okay.
are also now
Okay.
picking up in the market.
Uh-huh.
But Palladium has traditionally been the leader.
Right,
Okay.
right, right. Okay.
Currently, I think Zebo is also picked up, but
Mm-hmm.
Palladium has been the leader, and it has been then Zebu and Veloce alternately.
Okay. Okay, that's great. Okay, so I just want to ask you one question. These kind of a big test suits, right? Palladium or Zebu, whatever you are using for the emulation. Okay. So is it required for a big, huge or mammoth designs? If the designs are very small, for those kind of a design also, do we actually require this kind of a big, huge test suits? Or it's only for the big designs?
It depends on what kind of designs that you are
Mm-hmm.
uh,
Mm-hmm.
talking of. Uh,
Mm-hmm.
uh, because see, huge designs definitely will benefit from
Right, right. You know why I'm
uh,
asking this question? Because
emulation
getting
usage.
getting a license, okay, for these kind of a book test suits, okay, if the design is not that much huge, whether is it advisable for the company to buy that kind of a license if they are working on some designs which are having only microcontrollers? Okay, which are kind of a very small designs, right? And they won't be working on some 2 nm or 4 nm technology. They would be using some 90 nm or 65 nm technology. For those kind of design, whether it's recommended to use these two test suits, or they can have their own prototyping kind of a thing in which they can test, whatever the verification or validation, whatever they want to do with that. Yeah.
Yeah. So you touched upon a very interesting point here.
Mm-hmm.
See, emulation is like maybe uh, I will say a sword.
Mm-hmm.
And would you use a sword to cut a lemon? I mean, you will use
Right.
maybe a you know uh, knife to do it.
Mm-hmm. Yes,
But
yes.
if you want to use, if you want to really do something fast,
Huh.
that is where
Mm-hmm.
emulation will come.
Okay.
Like if you want to uh, use if you want to use it for some very important big designs, emulation
Mm-hmm.
is very useful. But you touched upon another very important point, that is prototyping.
Mm-hmm. Right. Yeah,
See,
so sometimes,
prototyping can
there
be
is a
there.
confusion between what is emulation and what is prototyping. So, viewers would be having that kind of a confusion in their mind. So, if you can just tell us the difference between prototyping and emulation, so it would be really good. Yeah.
Sure.
Yeah.
So see, I'll first talk a bit about prototyping as well, since we
Mm-hmm.
have come to this point.
Mm-hmm.
So prototyping is say you have a small microcontroller design, or
Mm-hmm.
you want to test it. You can as well test it on an FPGA. You
Mm-hmm.
put the microcontroller on say one or two FPGA boards that you get outside.
Mm-hmm.
You design it in such a way that can be uh, ported onto a prototyping system.
Right.
And that will really help to
Mhm.
prototype your design, and then you do the same things that you do on emulator. But here again, traditionally, I'm
Mhm.
just giving a very uh, what do you say, very conservative view. There are
Mhm.
advancements happening every day, so I cannot say that this is the case. But uh, predominantly with FPGAs, then you would prefer to use the in-circuit emulation kind of a flow,
Mhm.
where you could connect the real peripherals, because that is real silicon. Your design is in a real silicon, and then you can use your real peripherals, test the design, and then you can sign off. So for small designs, a smaller FPGA based system can be used. Definitely, it can be used. It is much cheaper as compared to a big custom emulator.
Mhm.
But again, there are for the same vendors that we spoke of, we also have prototyping systems from all the EDA vendors, which could be, say, Synopsys has their HAPS, then Cadence has the Proteum system. Uh, Mentor has they called it VPS. I don't know now if
Mhm.
there is some other name that is there.
Mhm.
They have come up with. But
Mhm.
there are various emulators, prototyping systems that are available,
Mhm.
and they are also very useful, relatively cheaper as compared to uh, our traditional uh, emulation technology. Now, the next question that you asked, and it's a very pertinent question: what is the difference between emulation
Mhm.
and prototyping? Right.
Mhm.
So, prototyping predominantly is run on FPGAs,
Okay.
and it is relatively faster as
Mhm.
compared to emulation.
Okay.
Emulation is relatively slower,
Mhm. Mhm.
but uh, emulation is very debug friendly.
Okay. Okay.
And like if something, see, when you're developing something
Mm.
and you're testing it, you need that debuggability.
Right. Right. Right.
Say waveform dumps,
Mhm.
or you need to have some ability to play around with the signals, force the signals on the runtime and stuff like that.
Right. Right. Right.
That debuggability is less in prototyping. So
Okay.
normally prototyping will be used at the later stage, and emulation will be used at the earlier stage of
Okay.
your development cycles, basically.
Right. 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 Okay. So, okay, can you just name the popular prototyping systems once again, just to,
Yeah, so
would be handy for our
Synopsys,
viewers. Yeah.
sure.
Yeah.
So Synopsys has HAPS prototyping system.
Okay.
Cadence has Proteum,
Mhm.
and Siemens has VPS, Veloce prototyping
GPS.
system.
Okay. 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 And do you have a different kind of a flow when you are going to have a prototyping system in place? Like
As compared
what?
to emulation,
Emulation. Emulation. Yes.
yes. So
Okay.
the tool suite for emulation, again, this is what I am talking based on uh, what
Mm-hmm.
we have as of today.
Mm-hmm.
So I'll talk of the cadence flow, Palladium
Mm-hmm.
and Proteum flow.
Mm-hmm.
So if we say, see, the front end flow for both emulation and prototyping is the same.
Okay.
Only the back end flow, where
Uh-huh.
one maps it to their own platform, uh,
Mm-hmm.
cadence it maps it to Palladium, while on Protium it maps it to FPGAs.
Okay.
That backend flow only changes.
Okay. 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 Only there's a
Rest of the
change in the
things will
backend
same.
flow. Okay.
Yes,
Okay.
yes, yes.
That's nice. That's nice. Okay. And there
So
are,
the idea
yeah.
is,
Mm-hmm. Sure. Carry on.
so the
Carry on.
idea is
Mm-hmm.
debuggability. Like when you are, if you are running something on Protium and if you see something is failing,
Mm-hmm.
you can go back to emulation, debug it,
Okay.
fix it,
Right. Right.
come
Right.
back on uh, Protium.
Sure, 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 sure. And there are the different other, applications for emulation. I think you have mentioned earlier, right? We have the low power verification application, right? So, as now the complexity of the design is increasing day by day, or, now we are working on a very, very smaller nodes, 2 nm, 3 nm, 4 nm. So, what do you think, in terms of those applications, what we are going to support with the emulation? So, how this whole complexity is going to change in the near future?
See, in low power, when we get to
Mm.
you know uh, as you go to newer nodes,
Mm-hmm.
all these low power features
Mm-hmm.
and more features will be required in uh,
Right.
these nodes actually,
Mm-hmm.
because you can
Mm-hmm.
squeeze in
Mm-hmm.
more logic, right?
Right.
Because
Right.
the
Right.
node has increased, so
Mm-hmm.
capacity is increased, so you can squeeze in more and more things, more and
Mm-hmm.
more logic can be put in,
Placed.
and
Right.
that makes the design complicated,
Mm-hmm.
and that is definitely going to affect emulation, and emulation is going to get more and more complicated,
Right.
if you say
Right. Right.
so.
Mm-hmm.
Earlier some one board of emulation would support, say, 4 million gates. Now it
Mm-hmm.
will have to support 8 million gates.
Right.
So it
Right.
has to
Right.
evolve as compared
Over a
to
period
that,
of
and
time.
over a
Right.
period of time. Yeah.
Sure, sure, sure. That's very good. So, viewers, I hope you have found this discussion very useful. We are just about to end the conversation, but I'm having a very interesting, question for our viewers. I think most of the people are actually looking forward me to ask you this question, that what is the kind of a job market, okay, pertaining to this domain, like the
So,
opportunities.
so as I said, see, for a good engineer,
Mm-hmm.
opportunities are always there.
Okay. Right.
So if you can debug,
Mm-hmm.
and if you can write code,
Mm-hmm.
you can try to help solve problems with respect
Right.
to
Right.
timing
Right.
or functional debug
Mm-hmm.
issues.
Mm-hmm.
Opportunities are there. Now coming
Right.
to emulation,
Mm-hmm.
see, if you have worked on any of these technologies,
Mm-hmm.
there is a lot of uh, uh, scope of growth.
Right.
Like you
Sure.
can gain experience and expertise
Mm-hmm.
in these
Mm-hmm.
uh, domains with these emulators, and you can also get good opportunities, because it's a it's a evolving field, right?
Sure.
As
Sure.
technologies are going to get complex, designs are going to get big, we need
Mm-hmm.
emulation which is going to
Mm-hmm.
grow. So it's a growing
Okay.
market.
Sure. Sure. Okay. And the entry level of the job is available for this domain for engineers,
uh, Entry level
or
is
you need to build some expertise before you switch
yes,
to this domain. Okay.
yes. So maybe initially you can start with
Mm-hmm.
a Verilog based verification and
Mm-hmm.
understand verification. Then
Mm-hmm.
gradually you can
Mm-hmm.
shift to emulation.
Okay.
That would be one way.
Mm-hmm.
Or if you get, see, it all depends on whether you
Mm-hmm.
get opportunity or not.
Right,
Uh,
right, right.
if you get opportunity, you
Mm,
can directly get into emulation group, and you get to
mm,
know and understand a lot of
mm,
things in emulation. That
mm.
is definitely going to be
Okay.
there.
All right.
So
Okay,
opportunities
viewers,
are
so
there.
now our time is up for this conversation, and I really thanks Umesh from the bottom of my heart who has joined this particular conversation today. Okay, and he has given his deep insight about the introduction of emulation. So we would be looking forward to have more discussions on this topic and the other topics like the dependency of emulation on the DFT or dependency of DFT on the emulation. Those kind of topics we are going to discuss in the commencing future. So thanks a lot, Umesh. Thanks a lot for your help. And thanks a lot for joining this session.
Thank you, Kshitij, and thanks
Yeah.
to all viewers. Look forward
Uh,
to talking to you more.
sure. Thank you. Thank you very much. Bye bye.
Thank you. Bye.